In 2023, Geoffrey Hinton, the godfather of AI, resigned from Google to sound an alarm. He estimates a 10 to 20% probability that artificial intelligence causes human extinction within the next 30 years. That warning comes as enterprise adoption accelerates blindly. Right now, 76% of organizations are actively deploying agentic AI systems that can make autonomous decisions, yet only 33% of those same organizations maintain any responsible AI controls. The vast majority are racing forward without safety nets. We are looking at a landscape defined by civilization-scale risk and a severe lack of operational control. The baseline models we rely on for oversight are entirely broken. The infrastructure building these systems is highly concentrated. Roughly 80% of global frontier AI development flows through just 5 specific corporate hubs. This concentration creates a crisis described as temporal inseparability. It is the direct link between the mistakes we tolerate today and the catastrophes we face tomorrow. If an institution cannot fix a present-day authentication system that misidentifies users 25% of the time, it mathematically lacks the institutional capacity to govern an autonomous superintelligence. We cannot mitigate future existential threats with abstract ethical guidelines. We have to construct rigid operational architecture right now. The root cause of these deployment failures is a pattern known as the economic override. This dual-axis graph illustrates the funding reality. The capability curve spikes exponentially, representing 98% of total research investment. Meanwhile, the safety and alignment line remains completely flat at the bottom, receiving barely 2% of funding. This financial disparity mathematically forces companies to prioritize speed to market. Safety validation becomes a cost center that delays launch and threatens shareholder returns. Under this intense competitive pressure, voluntary corporate ethics boards and safety pledges systematically collapse. Promises to audit models are quietly delayed when a rival product hits the market. We can observe exactly how fast this override happens in biosecurity. Researchers took a standard generative AI model designed to discover beneficial drugs and simply inverted its objective function to maximize toxicity instead. In just 6 hours, the system generated 40,000 highly toxic VX-like molecules. It required no specialized weapons knowledge, only computational power. Because AI capability scales at computational speeds, it will always overwhelm any ad hoc or voluntary human review process. To survive these computational speeds, oversight must transition from an optional afterthought into a mechanical, non-optional pipeline. The foundation of this pipeline is the Factics Methodology. Every AI deployment must link verified facts to actionable tactics and prove their success through measurable key performance indicators. As you can see in this workflow diagram, this structure operates on a constitutional layer called checkpoint-based governance. The data pipeline is deliberately interrupted by rigid red structural gates. These gates physically halt the deployment process. They prevent the AI from operating autonomously from end to end. The only mechanism that turns these gates green and unlocks the next phase of the workflow is human arbitration. The system absolutely cannot advance without explicit, documented human approval. If an engineer or reviewer spots a risk, the workflow pauses. Without explicitly designed stopping points, maintaining operational control over high-stakes AI systems is physically impossible. But placing a single human at these checkpoints creates a bottleneck and invites personal bias. To distribute authority safely, we use the HAIA-RECCLIN framework. This network graph shows a central AI core surrounded by 7 distinct operational nodes. These nodes divide the workload into specialized roles: researcher, editor, coder, calculator, liaison, ideator, and navigator. Data packets flow continuously between these nodes, forcing multiple AI platforms and human agents to cross-verify every piece of information before it advances. This constant cross-verification activates the system's most critical failsafe, preserved Dissent. When 2 nodes disagree on a risk probability, the framework permanently logs the conflict. It avoids forcing manufactured consensus to keep the pipeline moving. Documenting this dissent protects valid safety warnings. It ensures that critical objections cannot be buried by executive pressure to launch a product. This creates an unalterable audit trail. It shifts AI from an opaque black box into a transparent, legally defensible process. These governance architectures are not theoretical proposals waiting for a test environment. They are actively deployed production tools. The source manuscript detailing this analysis was authored in exactly 6 weeks using this specific checkpoint-based architecture. The production required a multi-agent execution. 5 different AI platforms operated simultaneously within the specialized RECCLIN roles, while a human arbitrated every single checkpoint. The empirical results are documented. The process achieved 96% checkpoint utilization and 0 hallucination drift over hundreds of pages. This proves that structured, governed AI collaboration successfully scales human productivity without sacrificing human authority or safety. The gap between AI capability and institutional control continues to widen exponentially. But institutional control over AI is not a technological limitation. It is a deliberate architectural design choice. We have to build operational muscle memory today. That means implementing verifiable checkpoints and distributed authority before the stakes escalate further. The goal is to deploy checkpoint-based governance across all enterprises, stabilizing local systems as a prerequisite for securing civilization-scale safety. Human judgment must remain sovereign over automation. Operational architecture is the only proven mechanism to enforce it.